Well, greetings everybody. Here's a question that came in today through Ask My Instructor from assignment 1.3. At least at the time I'm making this video, that's what assignment it's from. And it says solve this exponential equation. Okay, and there's some other instructions that come after that, but let's not worry about the other instructions at the moment. So I've written down the original problem and I've worked it all out, and I thought the video would be a little faster that way, and I'll talk about the steps that we use. Okay, now when we're trying to solve for an unknown is like x or y, a number we don't know. If we knew what x was, we would put the number that it's supposed to be in. Okay, so x is the unknown and it is in the exponent position. It's 5 raised to the power 7x plus 5. The x is in the exponent. Now when that is the case, we generally use logarithms to solve it. So what I do is I take my equation and I apply the natural logarithm to both sides. You know, ln is the natural logarithm. It's a logarithm with a base number of e. A logarithm can have lots of different bases, but if I have a logarithm and the base is e, where e is this number that has all kinds of uses. It's used for calculating compound interest and radioactive decay and all sorts of other things. But if I have log base e of some number, we just write that as ln of the number. Okay, ln means natural logarithm. It means a logarithm of base e. You could do this step here with any logarithm of any base, but the goal is to use a logarithm that our calculator can compute, and if you have a scientific calculator, it will have a natural logarithm key, and so that's why we do it that way. Okay, so let's just say we'll take our equation, natural logarithm on both sides. Why do we do that? Because there's a rule for any logarithm. If we have the logarithm of any base of something to a power, we can move that power out front and it's not a power anymore. Now it's multiplying. You see, because originally this thing I want to solve for, x, is stuck up here in the exponent position, and there's no way to move it unless you get the logarithm involved. Okay, so I take logarithm of both sides. In an equation, what you do to one side, you do to the other, keeps it balanced, and that allows me to move these powers out there like that, and now they're not powers anymore, now they're multiplying. So see, it says 7x plus 5 times natural log of 5, and then it says x minus 2 times natural log of 2. Okay, now what we do from here is we have to like rearrange the terms and solve for x. So we'll distribute through here like this, so both these terms get multiplied by the number natural log of 5, and natural log of 5 is a number. You can compute it with your calculator and see what it is, but it's a number. We'll treat it like a number, and then multiply through here both terms in that parentheses by natural log of 2. Then you'll get what you see in the next step. 7x times natural log of 5 right there, 5 times natural log of 5 here, x times natural log of 2 here, negative 2 times natural log of 2 here. Now, when we solve equations, the goal most of the time is to get the x together, all the terms with x in it, on the same side, and then get the numbers, the terms without the x in it, to the other side. I mean, it's sort of like if I said 2x plus 4 equals x minus 1. What I have over here is a more complicated version of that. The way I would solve this is I would move this x over here with this other one, and it would look like this, and I would move this 4 over there with that number. X is on one side, numbers on the other. And whoops, 2x minus x. Okay, like that. So this term went over there, this term went over there. So I'll get x equals negative 5. So that's the situation we're in here. I want to move this term over here to that side because it has x in it, and I'm going to group the terms with x together and this term over to that side because it doesn't. That will bring you to this step. Okay, now 2 more steps to be done. Both of these have x in them, and the way that I'll handle it for this type of problem is I'll factor out the x. So it's common to both terms, so I remove it. And how do I know that that can be done? Well, because I can remultiply and get back where I came from. If I can go one way, I can go the other. So I factor out the x, and then I get x times whatever would be left if you took the x out of each term. 7 natural log of 5 minus natural log of 2. Okay, now we're one step away from solving it. If I want to solve for x, if I want to get the x all by itself, if I want this to say x equals and have my answer on the other side, then I will divide by this entire number. I know that when you look at 7 natural log of 5 minus natural log of 2, you might not think like that's a number, but it is just a big complicated number. Okay, so I will divide both sides by it, and that will give me an answer of this number over here divided by this number over here, and that's what you see right there. Now let's pause at this point and let's look back at that question. So I've solved this problem at this point, to get down to right there. I noticed that the answer prompt says, can you give the solution expressed in terms of logarithms? Well, that's what this is. Okay, x equals, okay, whatever's on the other side of that equals is my answer. That's the answer in terms of logarithms. I could, if I wanted to, get my calculator and round that into a decimal, but that's not what it's asking for in this prompt. So let's put this in right here just like it is. So I got type of fraction. I get -5 natural log of 5 minus 2 natural log of 2. Okay, so like that, that's the top. Underneath it, 7 natural log of 5. Oops. I'm going to put parentheses just in case. 7 natural log of 5 minus natural log of 2. Okay, so there it is. Typed it in. I might double check it if I'm concerned. And I will check my answer at this point and see, and it's correct. Okay, so you see that's what it's looking for, it to express the solution in terms of logarithms. Now, like I was saying, I could take that number, like this is just a number. I mean, it's a number that most human beings cannot compute in their head. It would require a calculator. But yeah, I could get a calculator and I could, round it into a decimal. Now, depending on what kind of calculator you have, that could be more or less difficult, okay? If you're having trouble, like, maybe you get to this point, you get that right, but you're not ever getting the decimal right, it's probably just that you're entering it into your calculator the wrong way. One bit of advice that I can give you is, if your calculator is not giving you the correct decimal when you have all this correct, it's probably because you need some parentheses like that. So, you would do like this: parentheses, type in all that stuff on top, close parentheses, division, parentheses, type in all the stuff on bottom, close parentheses, press enter. That's you're probably just missing the parentheses. That's what I would say is the most likely explanation for if you're not getting the right decimal out of your calculator. In addition to that, it says, okay, here we'll put a decimal, but it says round to 2 decimal places as needed. So this is what I got out of my calculator, and there were more decimal places after that, but it says to round it to 2. So okay, let's see, I got -0.892. Would that be right? No, that's 3 decimal places. So how do I round that to 2 decimal places? 892 rounds to 89 if if I have it to 2 decimal places. Okay, and then that will be our correct answer for the second part. All right, so that's a total run through for this one. There are variations of the steps that you see here that I could show you, but I will just show you this because I know if you follow this, you can get it right, and of course that's the objective.